Assalamualaikum. My name is Nurafiqah Aliya binti Razin and I am supervised by Dr. Rahimah binti Haji Abdul Hamid. So my title for Bachelor Degree Project 2 is Effect of Sintering Temperature on Surface Topography and Density of the CNC Mill Zirconia Dental Restoration. So the introduction is dental CAD/CAM is a new manufacturing technique to fabricate dentistry restoration, but in the milling process from dental CAD/CAM resulting a scallop height and scratch grooves on the restoration surface. The surface roughness is the important properties that are responsible for microbial attractiveness in patient's mouth. So according to Tamada et al., microbial adhesion is enhanced by increasing surface roughness between 0.1 and 0.4 micrometer. So, sintering temperature also plays a significant role in grain densification and it affects the porosity and surface structure of the specimen. So, in this study, we want to investigate the optimal sintering temperature to obtain zirconia restoration with better surface roughness and porosity. Next is the relationship between problem statement, objectives, and methods. The first problem statement is from the zirconia restoration uneven surface, the rust surface, it can lead to microbial attractiveness to the patient mouth, according to Tamada et al. But unfortunately, according to Hamid et al., milling process produces a scallop height and scratch grooves effect to the restoration. So the objectives is we want to analyze the surface roughness of the heat-treated zirconia dental restoration by using a surface roughness tester, which is the profilometer. Second is density. So we know that density is a physical property that related to porosity of the microstructure. So a good densification can help to improve the grain growth of the microstructure. So the objective is we want to examine the porosity of the heat-treated zirconia dental restoration by using Archimedes principle. And in the density test, we use the densimeter for the apparatus. And lastly, in theory, sintering can improve grain size and reduce the porosity. And it is also not sure that the surface finish also can be improved or not. So the optimum heat treatment temperature to enhance the surface topography and porosity of zirconia dental restoration is unknown. So according to Miyazaki et al., sintering process at 1000 to 1100 degree does not affect the zirconia bond. However, Ting et al. Added that good mechanical properties can be achieved if the zirconia is sintered at temperature more than 1500 degrees Celsius. But the temperature more than 1600 degrees can lead to excessive grain development and increase the porosity. Therefore, in this study, we set the sintering temperature from 1400 until 1600 degrees. So the objective is we want to observe the surface topography of the heat-treated zirconia dental restoration by using the SEM machine. So in this methods, we use the scanning electron microscope and spatter coating material, which is gold and palladium, by using mini spatter coater. Next is the scope of the study. So the printed zirconia disc is used as the workpiece material. So there are three types of zirconia discs from different manufacturers, which are product 1 semi, product 2 Zandan, and product 3 Honchon. So the sintering temperature used in this study is set to from 1400 until 1600 because of the limitation of the disc. So according to Yin et al., it says that from the temperature from 1200 until 1600 resulted in compacted zirconia grain. Therefore, temperature is set to 1400 until 1600 degrees Celsius. Next, the porosity analysis was conducted using a decimeter due to the lack of porosity equipment at the laboratory. So the Archimedes principle is explored in this method, which has less density indicates a higher porosity level. Next, a cylindrical shape is used in this study for the surface roughness, surface topography, and porosity test. And we do not use the actual dental feature to avoid difficulty of surface roughness measurement due to the uneven surface of the actual restoration. And lastly, according to Vignaraja, holding time is set from 2 hours until 10 hours, that it can increase the densification of zirconia, which it will enlarge the growth of grains to cover up pores. So in the study, we set the holding time to 2 hours according to the manufacturer's recommendation. Next is the literature review. Okay. First, sintering. The surface roughness is very important in dental restoration. Rashid concluded that increase of surface roughness on fabricated ceramic restoration resulting in bacterial adhesion in mouth. Besides, porosity also vital in the dental restoration microstructure. So we know that sintering process is significant to improve the surface roughness and porosity of dental crown. Next is the density. Okay. Gemma et al. Claim that porosity in the structure of materials has decreasing effect on their mechanical properties due to the pores, and it can lead to fracture of the restoration. So figure 2 below shows the example porosity character. Next is surface topography. Okay, we know that Hamid et al. Discussed the effect of the cutter and workpiece during milling process that resulting scallop height and scratch grooves. So figure 3 shows the scallop height effect from the two workpiece movement. Meanwhile, in figure 4 shows the micropitting effect from the fabrication of zirconia discs. This is the micropitting effect. And lastly, in densification, Howe et al. Found the pores decrease gradually with increasing temperature at 1600 degrees Celsius as shown in figure 5. Next is the methodology. Okay. The flowchart of the study. The first process starts from selecting 3D model design, and we generate the STL file. After that, we prepare the G code, and next to dental milling process. And we will proceed to the untreated specimen and also for heat treated specimen. Okay, for untreated specimen, we will go through the surface roughness test and go to the density test, and lastly to the SEM. And as for heat treated, we will go to the sintering process first for the temperature from 1400 until 1600 degrees. And we will go through the surface roughness, and next the density test, and lastly the SEM test. Okay, for the CNC milling process, the test specimen is set to cylinder shape that is prepared using the Autodesk Fusion, as shown in this figure 6. So 3 zirconia discs used in this study, which is Zanden and Honchon. Okay, the machine setup parameter setting is the diameter, the thickness, material, types of sample, shrinkage factor, and also number of support. So the machining of zirconia is performed on the Ardenta 3D CNC milling. This is the machine, and this is the zirconia block. Next is sintering temperature. So in sintering, the sintering temperature and holding time, two significant parameters that affect the restoration's porosity. So according to Vignaraja, the holding time from 2 hours until 10 hours can increase the densification of zirconia that will enlarge the growth of grains to cover up pores in microstructure. So in the study, the holding time is set to 2 hours as recommended by the manufacturer. Table below shows the setup for sintering process. Next is density test. In density test, we use the Archimedes principle, which is we measure the dry weight of sintered sample divided by the weight loss in water, and we multiply with the density of water at room temperature, according to Kundu et al. So the process of measuring the density is conducted using decimeter. Based on figure 10, this is the measurement on the dry weight in air, and this is the measurement in water. Next is the surface roughness test. Okay, first we do the machine configuration. Okay, then we turn on the power of the machine. After that, we do some modifications of the measurements. So in this analysis, the travel length is set up to 0.225 millimeter due to the small length of the cylinder. Okay, after that, we do the calibration process. And next, we perform the measurement on the samples. So the surface roughness, the measurement, we examine on a flat cylindrical shape instead of the crown specimen due to the irregular and complicated geometric crown surface, which the surface roughness tester could not correctly read. So after the measurement, we do some analyze the output from the measurement. So this is the flat surface, the placement of the measurement, and this is the profilometer, and this is example of measurement. And lastly is the surface topography analysis. First, we need to do the sputter coating samples before use the SEM machine because we want to obtain a good quality image and also we want to electron discharge. Okay, this is the machine, SEM machine, and this is sputter coating. And based on figure 16, the scallop height effects on SEM image. This is the scallop height effect. And based on figure 17, the porosity shows in the temperature of 1400 degree, but in the temperature 1600 degrees shows the compacted microstructure without pores. Next is result and discussion. So first, from the zirconia dental machining, first we attach the zirconia block to the material platform. So this is the material platform. Okay, after that we select the STL file and then we adjust the parameter setting of the machine. And after we adjust the parameter, we start. And after that, the machine automatically stop after machining complete. Okay. After machining, we do the sintering process. So we adjusted a few parameter settings for the furnace, such as the final temperature, the heating rate, and also holding time. So total time taken for the sintering process is around 5 hours. So this is the sample prepared for sintering. So in graph 1, it shows the thickness versus diameter. So this is the result after the sintering process, which shows that the samples, the materials will be shrink after the sintering process. Next is surface roughness analysis. Okay, that the result shows that heat treatment can improve zirconia. So lowest value of roughness resulting a better surface finish. So based on these three products, we can see product 2 Zandan at higher temperature has the lowest roughness measurement. So the value of roughness will be decreasing, which resulting a better surface finish. Next is density analysis. So, according to Jin et al., the theoretical density is determined as 6.1 gram per centimeter cube. So, based on analysis on graph 3, according to the three products, we can see that product 1, semi, has the highest density at sintering temperature at 1600 degree, which is the value is near to the theoretical density, is 6.1 gram per centimeter cube. So, a good densification helps to improve the porosity. Next is surface topography analysis. So first, we need to perform the sputter coating for each of the samples for electron discharge on the surface. So as we can see in figure 23, this is the porosity of microstructure for untreated sample. So the pores shown. Okay, next for figure 24, it shows that there are still some milling effect on the milling process, but the texture has been improved. And lastly, in figure 25, shows the grain starts to grow with the increasing of the temperature. So the resulting of the optimal temperature is at the 1600 degrees Celsius. As for the conclusion, okay, for objective 1, the optimum temperature of 1600 could slightly improve the zirconia surface roughness. However, it does not eliminate the machining effect, and the scratch groove has been improved. For objective 2, the porosity of zirconia has been improved with the temperature of 1600 degrees, where the number of pores is decreased, and the densification also increasing. Therefore, sintering improves the grain size and simultaneously reduces the porosity. And for objective 3, based on the surface topography, uh, based on the STM image, the highest temperature of 1600 has improved the surface quality of the specimen. But still, this is not the optimum temperature because it does not eliminate the machining effect. So to conclude, at temperature 1600 is the best at maximum densification, reducing the porosity, but the influence on the surface quality is not evident. So there are some recommendations for future of this study, such as in order to reduce the measurement error, number of samples need to be increased to 5 samples to reduce measurement error. And lastly, the specimen of surface roughness test and density test should be different to observe the machining effect. The measurement using a stylus somehow leaves the samples unwanted mark and confuses us with the machining effect. Okay, that's all from me. Thank you.